not because of wind, not because of a truck going by. It's moving because of physics that have been working on it since the day it was built. And the movement is measurable, it's predictable, and for most houses, it's completely normal. Here's the part that's a little less comfortable. There's one type of movement that isn't normal, and the difference between totally fine, your house will outlive you, and you need to call a structural engineer this week comes down to understanding exactly what kind of movement you're dealing with. I'm going to show you the engineering behind both. By the end of this video, you'll be able to look at a crack in your wall and have an informed opinion about whether you need to worry about it. Not a guess, an informed opinion, based on the same framework engineers use. Let's start with the most constant driver of movement, temperature. Concrete expands when it's hot and contracts when it's cold. So does steel, so does wood. Basically, every structural material your house is made of changes size with temperature. This is called thermal expansion, and it's not a defect, it's just physics. The number for concrete is about 10 to 12 millionths of a meter of movement per meter of material per degree Celsius. That sounds tiny, but it adds up fast. Take a concrete slab, say a typical residential foundation, about 12 meters across. In a climate with a 40-degree seasonal temperature swing, not unusual in most of northern Europe or the northern US, that slab is changing length by about 5 millimeters over the course of the year. 5 millimeters of the foundation expanding in summer and contracting in winter. Every year, forever. And that's just the season-to-season movement. Day-to-night cycles are smaller, but they're happening 365 times a year. Your house is a machine that is continuously flexing, breathing, and adjusting to the temperature every single day. The second driver is the ground under the foundation. Soil is not a solid, it's a matrix of particles. Sand, clay, silt, with water and air filling the gaps between them. And that matrix changes depending on how much water is in it. Clay soil is the main character here. Clay expands when it absorbs water and shrinks when it dries out. This is called the Shrink-Swell cycle, and in clay-heavy areas, it's the single biggest driver of residential foundation movement. During a wet period, spring rainfall, heavy irrigation, clay soil swells. It pushes up against the underside of the foundation. The house rises slightly. During a drought, dry summer, water table dropping, tree roots pulling moisture out of the ground, clay soil shrinks and pulls away from the foundation. The house settles. This cycle repeats every year. And in areas with highly expansive clay, large parts of Texas, Oklahoma, Northern California, the movement can be 1 to 2 inches seasonally, just from the soil breathing. The third driver only happens once, initial settlement. When a building is first loaded, when the walls go up, the roof goes on, the floors get filled with furniture and people, it applies load to the soil underneath. The soil compresses. The building settles. This is completely normal and expected. Structural engineers designed for it. For most residential construction on well-drained soil, initial settlement is somewhere between 10 and 25 millimeters, about half an inch to an inch. It happens mostly in the first year or two as the soil consolidates under the load. Then it stops. On clay soils, this process can take longer, years, sometimes decades. The load is pushing water slowly out of the clay pores, and clay is not in a hurry. But here's the thing. All of this movement, thermal expansion, the shrink-swell cycle, initial settlement, none of it, by itself, is inherently a problem. The problem starts when different parts of the foundation move by different amounts. This is the concept that separates a structural engineer looking at your foundation from a non-engineer. It's called differential settlement, and it's the most important thing in this entire video. Uniform settlement is when the whole foundation goes down together. Imagine the entire slab dropping 15 millimeters evenly. Your house is now 15 millimeters lower than it was. You'd barely notice. Nothing cracks. No load paths are disrupted. The structure doesn't care. It's just in a slightly different position. Differential settlement is when one part of the foundation moves more than another. The northwest corner drops 30 millimeters. The southeast corner drops 5. Now you have a foundation that is no longer level, and the structure built on top of it, which was designed and loaded assuming it would be level, starts to fight itself. Beams that were designed to carry vertical load are now being asked to carry lateral load. Walls are racking. Connections that were designed for compression are seeing tension. The structure is being deformed out of the shape it was engineered for. The threshold engineers use is angular distortion, the ratio of differential settlement to the horizontal distance over which it occurs. The rough rule, 1 in 300, is where cosmetic damage begins. 1 in 150 is structural damage territory. 1 in 100 is serious. To make that concrete, if you have 10 millimeters of differential settlement over a 3-meter span, just under half an inch over 10 feet, you're already in the zone where cracks appear in finishes and door frames start to bind. That's how sensitive the structure is to uneven movement. This brings us to cracks, which is what most people are actually worried about when they find this video. Not all cracks are the same, and the shape of a crack tells you what kind of movement created it. Diagonal cracks, the ones that run at roughly 45 degrees from the corners of windows and doors, are almost always caused by differential settlement. The frame of the opening is trying to distort into a parallelogram as the foundation tilts. The cracks follow the line of maximum tensile stress, which is diagonal. These are the cracks worth paying attention to, especially if they're getting wider over time. Stair-step cracks in brick or block masonry follow the mortar joints, stepping diagonally up or down the wall. Same cause, differential settlement. The masonry is riding a foundation that's moving unevenly. In brick buildings, stair-step cracking is the classic early sign. Horizontal cracks in a foundation wall are different, and they're the one that should make you pick up the phone immediately. Horizontal cracking in a basement or foundation wall usually means lateral soil pressure, the ground pushing sideways against the foundation harder than the wall was designed to resist. This is the structural failure mode, not a settlement issue. It can progress quickly. Vertical cracks that run straight up and down, especially if they're narrow, uniform width, and not growing, are often just shrinkage cracks from the concrete curing. Concrete always shrinks slightly as it cures. These are usually cosmetic. The two questions that matter for any crack: is it getting wider, and is the crack on both sides of the wall or just the surface? A surface crack on plaster or drywall might be nothing. A crack that goes all the way through the structural masonry or concrete is a different conversation. Most of what I've described, the seasonal movement, the initial settlement, the hairline cracks in plaster, that's your house doing exactly what it's supposed to do. It's normal. It's been normal for every house built before yours, and it will be normal for every house built after. But there are specific things that cross the line from expected behavior into get a professional opinion. Diagonal cracks wider than 3 millimeters, about the thickness of a credit card, especially if they're growing. Any horizontal cracking in your foundation or basement walls. Doors or windows that were square and now stick or won't close fully across multiple areas of the house, not just one. Floors that are visibly out of level by more than about 10 millimeters over a 3-meter span. Gaps opening between wall frames and ceilings or floors. One of these in isolation might be explainable. 2 or 3 of them together in the same area of the house is a pattern, and patterns are what a structural engineer looks for. A structural assessment for a residential property is typically a few $100s. It's a cheap conversation relative to the cost of finding out after the fact. Your house is moving. It's been moving since the day it was finished. It will move every day for the rest of its life. The goal isn't to stop the movement. You can't. The goal is to understand the difference between a house that's behaving exactly as designed and a house that's telling you something needs attention. Most of the time, it's the first one. But knowing how to tell the difference, that's just engineering.